Okay, welcome to the next portion of the revision series. This is Cluster 3 Climate, Topic 2, right? The continuation from where we stopped. So, for this particular section here, we will only be looking at winds, okay? Specifically, your local and winds, which you already covered already, sorry. So, we'll be looking at global winds, okay? No longer land breeze and sea breeze, but understand that the concept here is still the same. Whenever we're looking at winds, we're looking at this idea of unequal heat distribution, and as a result of the unequal heat distribution, what do we encounter as a result of that? Okay, so always remember, for climate, one of the underlying things, or the most important underlying thing for the processes, is always heat and the unevenness of heat across regions, across locations, and how that affects the movement, okay, and creation and formation of winds. There are other forces that we will look at within this area, right? One of which, of course, is dealing with Coriolis effect. Okay, so we'll talk about that a little bit more just when we come to monsoons. Okay, so once again, these three your key problems. Always remember we're still dealing with heat as a basis. Okay, so sea breeze diagram, right? Sea breeze coming from the sea. So this is actually, if you can remember this diagram, this was how we started off discussing wind formation using local winds itself, right? So when you're looking at sea breeze, always remember one of the key things we're looking at is time of the day. So it's in the sun, and you're looking at the difference between location X and location Y, the difference in material type of surface, and consequentially the type of the rate that they are able to absorb and lose heat. Because these two areas, because of the different type of surface that is present, it actually affects the air pressure right above it. And it is not the surface that causes the wind, it's the air pressure movement above these two locations, these two different surfaces, that end up creating the opportunity for a wind to form. Okay, so daytime, once again, right? Your land heats up faster, your sea heats up slower, so the temperature above the sea is cooler compared to the temperature above the land. What happens is the parcel of air above the land being hotter will rise up, leaving an area of lower atmospheric pressure. Similarly, the reverse is on the sea area. This is actually cooler, so it creates an area of higher pressure. So wind will always move from high pressure to low pressure. Okay, high pressure to low pressure. So it moves from the sea, right where we are here, to land where we are here. Okay, forming the sea breeze. Right, so this is one of the two local winds that they can ask about. The second one, of course, is the reverse, right? The reverse, where you have a reverse in situation where at night the sea retains the heat a bit more than the land. Land, therefore, is cooler. The air above the land is cooler, it sinks down. The air above the sea is warmer, so it rises up. And consequentially, the air will move from high pressure to low pressure again, moving from the land to the sea, creating the land breeze at night. So that is the fundamental concept for land and sea breeze, right? So I want to move on very quickly to cover regional winds. Okay, regional winds. The key thing that we need to think about is you have two monsoons. Okay, one that is during October and February. Okay, October and February. When you think about October and February, this period of time, think of the two hemisphere, the northern hemisphere and the southern hemisphere, right? What you have in October to February, this period of time, is you have summer in the southern hemisphere. As a result of that, what you end to experience is in the southern hemisphere warmer temperatures. So once again, we come back to hot air rise, cold air sinks. So northern hemisphere, cooler temperatures, higher pressure because the air is sinking down. Warmer temperatures in the southern hemisphere. This is lower pressure. So if you think about it, where would the wind move? The wind will actually move down this direction, correct? From the high pressure to the low pressure. Unfortunately, right, this is not the only force at play here. So as the earth is spinning, right, the winds actually get deflected. Okay, it actually gets deflected. So what you end up having is something like this. As it moves towards the equator, it deflects to the right. Okay, from the northern hemisphere, it's moved down, it deflects to the right. So where we are in Singapore, right, what do we experience? We experience the northeast monsoon. Okay, we experience this and we call this the northeast monsoon because it's coming from the northeast direction. However, with the Coriolis effect, when it crosses the equator, it makes a full deflection, and then it arrives in Australia as the northwest monsoon. So technically, this is the same monsoon. Depending on where you are, it's called different names. Okay, right. So once again, another diagram to show you how it arrives as the northeast monsoon. How after crossing the equator, it deflects, and then it arrives at Australia as the northwest monsoon. Okay, now this is a little bit tricky. Just remember, in Singapore, where we are, it is northern hemisphere. So the winds still come from the northeast. The same wind will deflect once it crosses a right angle, once it crosses the equator. Right, so now instead of coming from the northeast, it deflects, then it becomes the northwest monsoon. Who experiences the northwest monsoon? Primarily Australia. Australia will suffer from all the winds and everything. Okay, where does the moisture actually come from to supercharge it so they hit Australia as the northwest monsoon? Actually, the Indian Ocean, this area here that I've circled, this is where all the moisture is picked up and then subsequently dumped on Australia when it arrives as the northwest monsoon. Second monsoon that is in your syllabus will be during June and September. June and September, this is the reverse. Right, June and September, if you think about your holiday plans, right? When you go to Australia in June and September, it's actually cold. It's winter time. So what we're looking at is a reverse situation. So cold, this part here will have, of course, high temperature, high pressure. This part here will have low pressure, right? And then the direction should be reversed, right? It should push upwards to the northern hemisphere. Similarly, it comes out as the southeast monsoon in the southern hemisphere, coming from this direction, from southeast. So it's the southeast monsoon. But once it crosses the equator, before it hits India itself, it will deflect. Okay, so this will deflect, and it hits India as the southwest monsoon. Okay, so the target area, depending on where the target area is, the monsoon actually, the name is dependent on where you're looking at. All right. But interestingly, for this particular one, if you look at where Singapore is, right, what monsoon is this? It is above the equator. So in Singapore, we still call this the southwest monsoon. So the naming switch only affects your northeast monsoon and the northwest monsoon. It doesn't affect the south monsoon. So at the end of this part, I want to just reinforce one common question that we always get. Do I need to explain what Coriolis effect is, how it works? Actually, no. Within your syllabus itself, you are only expected to be able to produce this idea of description of the deflection for the Coriolis effect. Although you've been taught and you've seen videos of how the Coriolis effect is generated due to the rotation of the Earth, right? You are not expected to explain that. So not to worry. You only need to remember how to spell it, and that it causes the deflection in the monsoonal winds as it approaches the equator, causes the deflection as it crosses the equator. Okay, so this is for Cluster 3, Topic 1, Part 2. Part 3 will be coming in a subsequent